Good morning. Welcome back. We'll be starting with our new chapter today. We will be actually switching our chapter. Instead of chapter 21st, we'll be starting with chapter 21. Chapter 21 is about standard template libraries. It's an easier chapter, especially before Thanksgiving. So you will be spending time working on an easier project as compared to chapter 20, which will require a little bit more time. So I switched it around, so many of you will be busy traveling probably. Anybody's planning to travel? Within state, out of state? Out of state? Within state. So some of you probably will be busy with your families. So I'm going to talk about those three components, those three major components. In this chapter, we talk about containers, iterators, algorithms, and there are different additional containers and algorithms and different types of concepts we'll be discussing. Some of these concepts we have talked about in the previous chapters. We will be discussing vectors and something similar we have talked about in the past. Sequence containers, lists, DQ, and again, some of these concepts we have really talked about, especially queues. DQ is double queue, so we'll talk about those. Stacks and queues containers, function objects, algorithms, sets, and multi-sets. And in order to use these concepts and apply these functions and libraries, functions and some of these classes, we need to use some of these libraries. When we actually need to include, for example, lists, we'll be including list library. Similarly, we'll be adding algorithm library, iterator library, DQ library, stack library, functional library, numeric library, set library. Of course, we don't have to include all of the libraries if they're not necessary in that project, but if you're using a specific app, such as you're using DQ, so when you're using DQ, you will be adding a DQ library, and so on and so forth. Okay, so when you see some of the projects handout or sample handouts I have or sample projects I have on the Moodle site, so you will see that some of these are listed in there. How do you include those libraries? Very simple. So for example, if I want to include a vector library, so just like what we have been doing with other libraries, so then you have the access to all the functions and objects and classes within that library. How do I declare something of that type? So this is a variable of that type, and I'm trying to declare a vector of integer type. So this is the list which can contain integer vector, and we'll talk more about it once we get to that concept. Okay, so that's our goal, to finish this chapter. I'm hoping that in an hour and a half or so we'll be done with the chapter. Hour and a half. The first 2-3 concepts are much faster. We have a pretty good understanding of arrays. Vectors are basically your dynamic arrays. We have talked about lists. We have talked about queues. So some of the concepts are pretty fast. So this is our goal. This is our calendar. So today we need to finish chapter 21, and we'll be working on assignment 6, which will be due on 26, which is Sunday of this week. Again, Thursday, Friday, and Saturday, there's no school. So if you have classes with other instructors, there's no school in those 3 days. So we have today, Tuesday, Wednesday, and probably Sunday to work on a project. And of course, you don't have an access to the open lab Thursday, Friday, and Saturday. So plan accordingly and schedule your schedule your calendar accordingly. When we come back next Monday, of course, we have a lab on Wednesday. So if you want to come work in a lab, we have a lab on Wednesday as well. So when you come back next Monday, we'll be working on chapter 20, and we'll be working on our last assignment, assignment number 7, which will be due the Sunday of that week as well. Okay. Finally, the two weeks from now, we'll be taking our final exam based on chapters 20 and 21. So anything we discuss today and we discuss Monday, that will be included in our final exam. So final exam is not comprehensive exam, similar exam like our previous exams. Okay, shall we start? You guys are ready? All right. So if you remember that we have pretty good idea about some of the concepts such as let me just go look at the objectives, such as basic operations on arrays, and what if my arrays are not practical for me to use. I need something more practical, something which during the runtime I want to expand my data. I want to add more data. So there is a concept about vectors. In order to use the vectors, what standard template library has included, they have included these three components: containers, iterators, and algorithms, which means, if you remember, when we were discussing linked list, we had to control a lot of things. We had to monitor where my head pointer is, where my which one is my last node, which one is my first node, especially if I want to search it, if I want to sort it, if I want to add something, insert something, delete something. So we had to write all that code and monitor that code and make it functional. Guess what? Somebody has already done all that for us. So we didn't have to learn chapter 16 because somebody has done all that stuff. They have created all those functions for us. So in this standard type template library, we'll learn all those functions which we had to do manually for in order to insert something, search something, sort something. All those things are practically available to us. So what we are going to talk about, many of the features available in standard template library, show how to use those tools. And it will make your programming much easier. The question is, why didn't we learn about this one earlier on? Because we wanted to see what exactly is included inside there. We wanted to see how the search works, how the insert works, how the delete works. What if we don't have the access to the standard template libraries in other cases, so we can actually create our own programs. So this includes lists, stacks, and queues, and all sorts of data types we have learned in this class from the beginning of the class. So remember, we spent the first couple of weeks on lists, then another couple of weeks on stacks, another couple of weeks on queues. Here, we'll be learning some of the tools are available, some of the operations are available to make it easier for us to access the data, manipulate the data. So these are the three containers, three types of components: containers, iterators, algorithms. Containers, iterators, these are class templates. So these are available as templates. Your iterators used to step through. So if you want to go from the start of your list to end of the list, so guess what? We have something available such as begin function, end function. And you don't have to manage any one of those lists or stacks or queues. It manages it for you. And we'll see that how it works. And also we have some of the manipulator tools. We call them algorithms, how to manipulate the data. All those things will be available to us as well. So manage objects of given type, three categories: sequence containers, associative containers, and container adapters. So these are the three types of containers available. And in sequence containers, we have vectors, DQ, and lists. So this is under sequence container. Remember, we have containers, algorithms, and iterators. So these are the three types of containers, sequence containers. And as I indicated, if you want to declare your vector, so you will be including that library, and you can simply declare the vector type, what type of data I want to create. This will be the name of your variable, as I indicated on the board. Now, what is a vector? Vector is a dynamic array. Vector can expand during the runtime. Arrays, you have to provide the size at the time of the creation of your array. Vector, you can start with one element, and you can expand throughout. Let's say you're adding more data, more customers, more products, that can be added. So here's an example of adding a string vector. So basically, it's an array of dynamic array. And you can add any kind of vector. And it contains many kind of constructors because it's a class. It's a class available to you. So many constructors are built in. They're available to you. Many of these functions, we'll look into some of the functions are available. I'm not going to go through every single function, but you'll see a lot of these things are available. How to initialize it, how to start it, how to find the end, how the beginning, and it allows you to do all sorts of things. So for example, here's my vector. Here's my vector, and I just took directly from the book. Int list is a vector, integer type, integer vector. And if I want to add data to this vector during runtime, notice that there's no size given here because it's a dynamic array. So I can add data here. I'm adding 4 pieces of data. And the function pushback is given to me. Pushback will allow me to add piece of data into my vector. So just like you imagine an array, so 13 is added, 75 is added, 28 is added, and 35 is added. So all the data will be added to the vector. Then if I want to access the data, just to verify it, exactly the way we did it with arrays, you can use a simple for loop right here, simple for loop, and you can actually verify the data. And you can see that I run through the loop and I see, okay, just confirm the data with me, and it confirms the data with you. You can also do some manipulation if you want. Here I'm doing a simple manipulation and verifying the data again. And then instead of you doing the size and checking on how many pieces of data are added, well, we have some kind of looping mechanism available called iterators. So these iterators, I'm declaring that iterator class. I'm saying list it. This particular list it is of iterator type. So now, remember the list it has the starting point of my vector. So it figures it out where this particular vector begins. And also it has an ending point. If it's not end of the vector, continue to loop through this one. So, and then it displays the data. So that's a pointer. It's a pointer type. And of course, when we use the dereferencing operator with the pointer variable, it displays the data. It's going to spit out the result. So instead of using square brackets and index, I can actually display the data this way as well. So in this case, you don't need to know what was the size of the vector. In the previous case, notice that I had 4 over there. So because of this iterator, it loops through your entire vector. And this is applicable in many cases. So it becomes easier for you to track the data, access the data, manipulate the data. So you have a begin function available for this int list iterator, and end as well as for this particular one. And you can do ++ list, and it should show you all the necessary data. Now I'm going to run this one in a minute. Now if you do this one, what do you think what's happening here in this line 22 and after that? What exactly am I assigning to list it here? So this is where this is the name of my vector. What exactly am I assigning to list it iterator variable? I'm assigning what? The first element, right? I'm assigning the first address of the element. So I'm actually at the first element. And then I'm incrementing, go to the second element and the third element. So then I say, I want to insert something here. Imagine if you have to do this by using traditional linked list, and then you have to find where you want to insert it. Remember, we used current pointer. Current pointer allowed us to make a space between 2 existing nodes, insert something, take the previous node link, put it to the current, take the current link, put it to the next one. So we actually had to do all that manually. Here, everything is done for us behind the scene. So all I need to know is, where do I want to insert the data? I want to insert the data after, let's say, 2 nodes. So you just simply increment the nodes and use the insert function. I want to insert 88, and I want to use this iterator. Where do I want to insert? I want to insert in this list. So this is the location. This is the pointer, just like a current pointer. So you're telling the location, that's where I want to insert, and this is the data I want to insert. And guess what? It inserts the data right there. So makes your coding all that code, all those functions we had to write in linked list in chapter 16, here simply we can call insert function to do the same thing. So really makes it easier for us. What about the next one? What's happening in the next line of code? I'm just simply displaying the data just to verify it. And what about this one here? What do you think, what's happening here? I'm calling some existing functions of this iterator sequence container. So, and I'm saying, I'm going to call the front function, show me the front element, show me the back element, show me the size of this vector, show me the maximum size possible. Maximum size is for this integer vector, how many elements I can store, how many possible elements I can store, how many possible pieces of data I can store. So it's going to tell me that one as well. Imagine if you want to do this manually, then you have to figure it out. And also this function basically clears all the data. Now if you remember, we did create empty function. If you remember, if you go back a few weeks, we did create empty function. But we had to manually create that empty function. We did create a front function and back function. The front function basically returns the front element. The back function basically returns the back element. And we can also probably figure out the size of our arrays or linked lists. Here, we just simply make a one-line call, and it allows us to do those kind of similar things. So makes your programming much easier. So let's go through, cycle through this one. Let's see what results do we get. So I'm going to show you the top portion first, where we insert the data. And I'll put a system pause here. Okay, I'm just processing it and running it for the camera. And let's look at the results. Okay, so I created a vector right there. I pushed 13, 75, 28. And 35. So as you can see, list elements 13, 75, 28 are added. Did I create some kind of insert? No. I just pushed them. And the push function is available in the vector library. Pushback is available. So it basically creates that vector or dynamic array for you. Then I'm simply displaying the data, which is being displayed right there. All right, let's hit the enter key and let's see what happens after that. So here in the next line, I'm simply multiplying. As you can see, you can still use the vectors and do some kind of manipulation here. I'm simply multiplying with 2. So this becomes 26, 150, and so on and so forth. So you can do any kind of manipulation of the data as well. Then we are using this pointer, iterator pointer, listed, because we want to use that pointer instead of us controlling how to insert, how to check the front, back, how to check the empty, all those things. I want to use this iterator in order for me to not only cycle through, but do lots of other kind of data structure manipulation. So it allows me to access the begin function. And the begin function will be added to the listed. So that technically I'm saying this is where the list8 pointer is going to point in the beginning of the vector dynamic array. Once it does that, I also have the access to the end function. So which is right here. I say start with the begin function, and that will be the end function, and cycle through this one. And it displays the data exactly in a similar fashion. But this time using the iterator. So this line of code is different. This line of code is different from this one, although we have the same results. Here I'm manually processing it. Here I'm using an iterator to cycle through. Iterator, remember, we just saw the definition. It allows you to loop through your data, different types of data. And it is applicable not only in the linked list or dynamic array, but also applicable in other types of algorithms. Okay, so same results. And then finally, we come back here and we insert 88. And as you can see, so a way of pointing in the beginning, we actually increment twice. So this is the beginning right here, beginning of the vector. We increment from here to here, and this is where we insert the data. 88 is being inserted right there. So we simply say, tell me where do I want to insert the data, and it inserts after the second element. How easy it is to insert the data. I don't have to write the function to insert the data. When you insert the data, it's a very long process to figure out where you want to insert the data. Same thing with delete the data. But once you delete the data, you have to put those two nodes together. When you remove something, you have to put those two nodes together. Here it's doing it for us. And finally, you can actually look at some of the final things. What is the front? The front function gives you the first element, 26, as you can see right there. What is the back? Back gives you the last element, 70. What is the size of my vector? Maximum size, in this case, 5. And the size and the maximum size will be this much. So we have 3, 4, 5, 6, 7, 8, 9, 10. So it's about more than a billion elements can be stored. And once you run the empty function, it clears all the data from your dynamic array. So literally, it makes your coding very easy. So you don't have to create a delete function, go through the entire dynamic array and delete every single element, clear the data, clear the counter. All those things are done for us. Don't you think it's easier? This is much, much easier. Are you going to use this kind of stuff at the workplace? Absolutely. Absolutely. Did you use this kind of stuff, Christian?
Yeah, all libraries were recommended. So if you wrote something on your own, it would be bad practice.
That's right.
Reinventing the wheel.
That's right.
So if we don't find a framework for the library,
yeah,
then it's a special case.
Yeah.
We have to bring it up at hours. So yeah.
Right. Right.
Or
Yeah.
open source.
Right. So also you need to know both, because if you're conceptually not sure how this is happening in the background, then you probably have difficulty understanding the real code. So if you need to know how it's doing it in the background. At the same time, you need to know how to use the functionalities by using the existing functions. All right. So that's our first sample code. I ran the vector sample code. That's the one I just ran for the online students. Vector sample code. Yeah, Christian?
Is the vector, can it also be a hash map or no? Can you send template to be a string or?
You can use a string, right?
I'm asking if
Yes.
the vector also.
Yes. Yes. Yes, I believe so. Yeah.
How do you know the names of the functions to use for the library?
How do you know to use? So the book actually has all the major functions shown. So if I show you this one here, so you can see there are a lot of these things are already discussed in the book right there. It tells you at, it tells you index, it tells you front, back, it provides you brief definition, capacity, empty, size, maximum size. It gives you additional, such as erase function, clear at the beginning and end, insert. All these things are already available. So
in the program itself, like Visual Studio, is there a list of the functions? Or?
no, you just need to. When you click the dot notation, it's going to show you what's available. Okay. But you still need to know how to use them, and you can actually quickly, you have a manual to look at it, some kind of manual, or you probably have used it, or probably you can Google on the Visual Studio library. You can find out. Christian, how do you?
Usually you Google online for documentation.
Right.
So depending on the language, Python. This one I use often C++.com as a reference.
So C++.com. Yeah.
That's a quick reference. Other
Yeah.
sites have, more like MSDN or whatever that's called from Microsoft.
MSDN, right.
Very complicated, but very advanced.
Yeah, the Microsoft, they have their own library, and I agree with Christian. I don't normally go to that library. The way they show the sample, it's not easy to understand. But in my CS11 class, I do recommend C++.com. It's not fully authenticated, but it gives you a pretty good sample, how to implement it. It shows you what functions are available, and so on and so forth. Yeah. Okay, so now we will move on to another list sample code. You'll see a lot of similarities. So again, for the online class, I'm going to demonstrate how to use list and its functionalities available. And for this one, you probably want to include the list library. As you can see, I've also included the iterator library and algorithm library, and if it's used, I'll show you where it is being used. All right, just like a vector, I'm going to create our list, and in fact, list 1, list 2, list 3, list 4. I'm creating 4 lists. 4 lists of integer type. And I'm also doing something different here. I'm actually using cout, and the cout, if you remember, if I want to display the data by using the iterator, and it's an integer data, so I'm using this screen variable or screen function, and in this function, this is basically, I'm telling that this is the purpose. I'm trying to display on the screen and add a space after that one, just to spit out the results. And I'll describe further once we get there. So this one is designed for integers. Just like our vectors, I'm pushing the data here. Notice that there's some repeated data. 58 is repeated. So 58 is repeated here as well. And it is deliberately repeated. And we just want to see if there's a duplicate data. And just like what we did with our vectors, so we have a function called begin and function called end. So I'm copying this one. I'm copying this linked list and copying this, calling this copy function. And I say this is where the data starts, this is where the data ends, and this is where I want to present the data. So this is where data will be presented. This is basically for CR purposes. And then I take my list 1. List 1, this is what the list 1 looks like. List 1 has all the data. And I assign to list 2. So I'm taking all the data which I added, I pushed back, I'm assigning to list 2. Then again, I'm doing the same thing. List 2, start from the beginning, start with the end. This is the end, and for output purposes. And then show me, and once we run, you'll see how it works, but show me if there's anything unique about it. Show me the unique data. Instead of showing me all the data, which you'll see in the previous execution, just show me the unique data, which means exclude 58 if it's repeated. So then after removing the consecutive duplicates, copy that one and display that one on the screen as well. Now imagine we talked about different types of sorts. There was a chapter on sort. So here, I don't have to write it down. It's actually available to me. I can call the sort function. So apply the sort on list 2. I can apply it to other ones as well. Once the sort has been applied, show me the data again. So it's going to sort the data for us. Then here's my list 3. This is a new list. Add more data to list 3. This is a new list. And display the data. And once the list 3 had been added, add list 4, display list 4, And then notice that list 3 and list 4 are created. Then I'm going to splice. So list 3 dot splice begin and list 4. Do you want to guess what exactly that means by splice? So put it together. More like a merge. Okay. So then I'm saying take the list 4 because I added some data to list 4 and list 3. So I'm going to splice list 3, and this is the beginning of the list 3, and maybe add list 4 there, and then verify the results. Then we do the same thing with list 3, sort it here, and display the data, and then merge list 2 and list 3. We are merging list 2 and list 3 here, and verify the results. And we can go on and on and on. There are a lot of other things we can do. Now, why I'm showing you this? Because remember, I didn't have to write ADT, abstract data type. I didn't have to declare anything. I didn't have to define anything. I didn't have to implement anything. Personally, everything is done for me. I simply need to know how to call these functions. I've declared a list, linked list. It's doing all the background work for me. I just need to figure it out. How do I put two lists together? How do I insert something? How do I sort something? How do I do all those things? And it's doing all those things for me. So this is the beauty of standard template library, that it's doing all sorts of work for us without us doing most of the job. Okay? So this, once I run it, you will see the results are really simple to understand. So I'm going to scroll up here. So here's my list 1 right there. I'm saying show me the list 1, and the data which was added, it is displayed right there. Then I believe I copy this list 1 to list 2, and same data is copied. I assign list 1 to list 2, and we verify it. It's exactly the same data. Once that's done, I'm removing the consecutive or duplicates. So here you can see only consecutive duplicates, not all the duplicates, but 58 was repeated 3 times. So it has removed the extra 58. So you can simply call a function which is a function called unique. It allows you to remove the duplicates. And 58 was repeated 3 times. Now there's only 158 in your data. And then we can sort the data. Here we are sorting the data by calling a sort function. And the data which was not sorted before, now it is in an ascending order sorted. Notice that when I sorted the data, it sorted the original list, which means that you can see 58 3 times again. 58, 58, 58, and 58. Also, there was a last 58 that was also added in the sort, and 93. I can make it unique, and now it will just remove the extra 58. Now, when I call the unique function, it's not removing anything. It's just showing you the unique sorted data. Just like when you do the filter in Excel, the filter doesn't remove anything. It doesn't display the second time. You can actually filter in a way that it's not removing the data. It's just not showing you the duplicated values. Then we add list 3. Here's my list 3. So I added 1, 2, 3, 4, 5 elements in list 3. These 5 elements are added. Then I believe copy this list 3 to list 4. No, list 4 actually is a new data. -2, -7, -8. That's your list 4. This is your list 3. I'm going to splice them now. So when I splice them, and here it is. So let's see what exactly we are doing. We are saying splice, and after removing the elements of list 4 into list 3, not moving the elements, this is what it looks like. So here's your list 4, -2, -7, -8, and other data from list 3. Then after that, we actually sort and display, which after sorting list, so data is sorted. So this data, which was not sorted earlier, it is sorted here. -8 is smaller than -2, so it comes before -2. And then we do a couple of more things. Let me see if I can scroll down. So I'm merging list 2 and list 3. So that's where the merge function is being called. So list2.merge list 3. So after merging those two, remember the list 3 we actually had spliced already. So it's a bigger list. So I also merged my list 2 into it. And if we go back, we can look at verify list 2 started, I think, at 23, I believe. So this was list 2, 58, 4 times. So it is added to that one. Then we can call the unique just to see the unique values. So this is really, really cool that we can actually call these functions. One-liner functions to insert something, to remove something, to find the unique, to search, sort, all those things. So makes your coding much, much easier. If I were working on a project, I would be very excited to use these existing functions, because if you're creating all of your own functions for insertion, for deletion, you have to verify, test, and test. Here, everything is already tested by somebody else. You're just learning how to use those functions and just implement them into your code. So this was very similar to what we did with vectors. Very, very similar. So this time, instead of using vectors, we use the linked list by using the list library. So this is the list library. Now we'll talk about DQ. So DQ is a double queue. I'm going to actually show you a definition of this one for the record. And the copy function which I talked about, it's available. So if you are reviewing in your book, the copy function which I showed you, it's available. It describes it, how it works. All right, here's a DQ. So DQ is double-ended queue, implements as a dynamic arrays, like vectors. A DQ can expand in either direction. So you have one node, you can add data this way, or you can add data this way. So that's why it's called double queue. Now, we did talk about something like that when we talked about linked list. Doubly linked list, yeah. That's a doubly linked list. Again, if you're creating doubly linked list and all the functions and abstract data type, it becomes a little bit overwhelming for a new developer, because you have to manage everything, you have to test everything. Here, we just use the existing functions available to us. Again, elements can be inserted at each end, and you need to include a DQ library. Okay. All right, let's take a look here. So again, for our online class, we have to include the DQ library right there. And I'm using this particular variable, integer DQ. That's the variable of that DQ type. So it's more like a node. This will be a node. And when I run this pushback function, the 13 is added in the node, and it has two links on each side. So 13 is added, it has two links on each side. So I can add 14 on the right side and 12 on the left side, for example, if it's a sorted DQ. So as you can see, we are adding this data, and then I'm actually verifying the data just to check. And in fact, let's run it just to see. So when I run this one, and here it is. So this, I added this in the DQ, 13, 75, 28, 35. As you can see, it's not sorted in any order. We just added the data. probably on one side of the DQ. All right. Then I can access and see if I can add something in the front or add something at the back. So I have the access, and I don't have to figure it out where my head pointer is, where my current pointer is, where are my other pointers, temporary pointers, all sorts of pointers. Here, I'm going to say you take care of it, because I want to add 0 in the front and 100 in the back. So if you have a list, you want to add 0 here and 100 at the end. Okay, so let's say you have 4 elements. You already have added 4 elements. So imagine if you have to add something before the list, before the DQ, then you have to figure it out. You have to have 2, 3 different pointers in order to figure it out. Here, I simply call the front function and back function, and those 2 values will be added. Once those 2 values are added, then data will be added. Here's my original link DQ, 1375. So 0 is added before that one, and 100 is added at the end. Just by calling the front function, push front, and push back. So those 2 functions will allow us to add the data in a specific location of your DQ. Okay, so what do you think pop does? Pop function. Removes it, yeah. So pop will remove how many elements in this case, Sean? It's going to remove twice, right? We say pop front twice. So don't you think it's going to remove 0 and 13? Say pop front, so remove those 2 from the list, or in this case DQ. So when we do that, so we end up with 75, 28, 35, and 100 because the first 2 elements were removed. How easy it is. Cannot tell you how easy it is. So what do you think, Anthony? What do you think these 2 functions are going to do? Pop back, pop back. Right, so it's going to remove the last 2 elements. You're right. So this one and this will be removed. So we'll end up with 75 and 28. And let's verify it. And that's exactly what happens. 75 and 28 is left in the DQ. Really, 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 really simple way to remove something, add something, insert something, merge something, splice something. And literally, and like I started my discussion, I said we should be scratching our head. Why didn't we discuss this earlier? Because we needed to go through the process in order to get here. So, when you have been playing certain sport, like tennis or soccer or whatever sport you play, or basketball, you don't even have to look at the basket to throw the ball. You just throw it and it happens. Why? How come it happens in such a way? Because your muscular memory, your coordination, all the other limbs of the body, they work kind of harmoniously. They work together. So at this stage, it is expected, this is the last chapter, data structure class. Typically, you find this kind of chapter in the last, at the end of the book, that they believe that you are working harmoniously. All the limbs, all the functionalities, they're working together. So at this stage, you don't need too much effort. And that's exactly what we are doing. We are not putting too much effort. Now here it is, DQ it. And I'm storing the beginning in that particular pointer. And I'm incrementing the pointer. Then I say insert 444. Just like what we did in the previous one as well. So technically, I'm trying to insert something in between here. So I assign DQ8 pointer in the beginning of the DQ, and I say increment, go to the next element. This allows you to increment, go here somewhere, and insert 44. So hopefully, 444. So hopefully 444 will be inserted in my DQ. How easy to insert? Really, really easy to insert. So my DQ actually has a 3rd element. What do you think what's happening in this line of code? What's happening here? So I'm saying int DQ dot assign 2, 45. So I'm saying after assigning 2 copies of 45 in my DQ. So that's what we are trying to do. So I'm assigning, like Sean is saying, 2 copies of 45. 2 copies of 45 in my int DQ. So 2 copies of 45. So once I say, okay, show me, and it shows me 2 copies of 45, then what do you think what's happening here? Push front and push back. So push allows you to add, right? Push, that function allows you to add. So in one case, I'm pushing in the front. In one case, I'm pushing at the back. So hopefully, I'll be adding -10 and -99 in 2 different ends. So once that happens, you can see -10 is added in the front and -999 is added in the back. Okay? Yeah. So that was your int DQ, and what we did, you assigned new data to it. You assigned new data. You basically said, I'm going to kind of overwrite.
Okay.
So
just erase it.
right. And then once you insert, so you can see that you can easily, we did check how to remove it, how to add in the beginning, how to add in the end, how to sort it, how to do all sorts of things. All sorts of things are really simple to do in DQ. Okay? So that's your DQ. I'm aware that there's a lot of repetition. The similar functions are repeated in this case. And that's how exactly the design is. The design is that once you know how to use, for example, vector STLs, the standard template libraries, they're very similar in other concepts as well. That's by the design. It's not that there's something wrong with the code. It's just that's by the design. All right. In this case, what we are going to do, I think I didn't copy correctly. Let me go back here. All right, I'm going to show you stacks and queues. And we are kind of familiar with stacks and queues. Remind me, what is a stack? So stack allows you to order in what order? What is the order of stack? We have 2 ideas. One concept is called LIFO. One is called FIFO, first in, first out. And queue, and the other one is last in, first out. So what is a stack? Stack of books, first in. So LIFO, last in, first out. So that's LIFO, right? Because stacks of books. So the first book came, it was at the end or at the bottom. So that's your stack. In case of queue, the first in, first out. Queue in front of the bank teller, for example. The first person comes in, he or she will be served the first time. So this is our stack. So we are creating a stack of integer type. Now imagine just this line of code, I'm creating a variable of stack type. I have to write a lot of functions. I have to write an entire ADT. I have to create so many different functions just to write that line of code. Here, everything is done for us. So I'm creating a stack, which means I'm going to stack 16, 8, 23 in that order. Then let's verify it. We display it. Also, I can call a pop function. Now, pop function, because the stack actually is a LIFO, last in, first out. So most probably the last item which is added will be popped out. Then I also can call the top function, and we did write these functions when we were writing stacks, the top function, just to see what's on the top. And then we can verify what the results are. And here I will display the data. I'm displaying the data, and it will allow me to see what's inside the data. All right, so when I run this line of code, and let's verify it. So the top element, it's telling me top element is 3. So I want to see the top element. It shows me the top element. Then I call the pop function to remove the topmost element. And then and originally my top element was 3, and it was popped out. It was removed because of this function here. Then I ran my stack again, and I said, show me the data. So 28. Okay, let me see if I can. Did I call the pop twice? All right, so we have the top element is 3. That's correct. We call the pop function. So 3 will be removed. Oh, yeah, it's correct. It's correct. Tell me what's happening here. So looks like we did remove 3 because that was the last element. We did remove 3. So how did I get 21st, then 8, then 16? How did that happen? Yeah, I'm displaying top to bottom. So that's because I'm saying, show me the top, show me the top. Every time, show me the top. So it's displaying from the top to bottom. You're absolutely right. So 20 will be displayed first, then 8, then 16. So it's not from bottom to top. It's top to bottom. Okay? And that's what we do in this case. All right. How do I do the queue? Just like our stack, queue. So here we are adding something to the queue. Remember, queue is a first in, first out method. It uses that one. So 26, 18, 50, and 33 are added. I want to see what's in the front, just like what we saw in the earlier one, the top. I want to see what's in the back. I want to pop it. I want to see the front again and maybe display all the content. Let's see if we agree with this particular one. So here's my queue. So the front element is 26. That was the first element which was added. So first element is 26. And I agree right there. 26 is added first. These are in the back. So this is like a queue. This is like a line. That's the first which will be served. So I'm looking at the front. The front is being shown here. The last element, I'm looking at the last element. Last element is 33. And I'm calling the back function. Let me move this one a little bit. So you can see the back element will be displayed by calling the back function. So back element is being displayed right here. Then I'm popping, and I call the pop function. So pop function basically removes, and once I call the pop function, so my original list was 26, 18, 50, and 33. And 26 was the first element. So when I pop it, 26 is gone. Now I end up with 18, 50, and 33. 18, 50, and 33. So in other words, the first customer is served. So first customer is done. So we have now 3 customers left. And that's how your DQ can be handled. Now, if you remember, when we worked on our queues, we spent, I think, a couple of weeks on queues. And we had to write all sorts of functions on our own. Here, in just one line, we can call those desired functions. Makes your coding really, really, really easy. And that's what I was thinking yesterday. I actually changed the format yesterday. I was thinking that most of you going to eat too much turkey, and you'll be busy with your family. So it's easier if I give you something simpler code. The code itself, once we get there, I'm going to provide you the code. I'm going to ask you, can you convert this code into stacks and queues of STL stacks and queues? So all you have to do is maybe add a stack library, queue library, maybe add the data from the list to the stack and queue, and show me the data and manipulate the data. And honestly, here I'm actually adding too many of lines of code. your code might be much simpler based on what we are looking for. While we are here, let me show you what I have. So what if I give you this data here, so we have individual's name and their GPA. So we have GPA and their names. Really simple data, maybe 15, 20 of them. And what if I say this data is already available? Let me go back here. So this data is already available to you, and the program is already available. I'm going to give you the program files as well. And redo this program so it uses the STL list and STL queue. List and queue. So I'll give you the code, convert that code into STL, list and STL queue. Currently what I have from chapter 16, which means I have a linked list with ADT and implementation of ADT. So I'm providing you what it looks like. So currently I have your stack ADT, my stack implementation, and the main function. So this is a functional program. It works. Your job would be to convert this into the STL list and STL queue. Okay? Yeah.
Do you mean like manually each name or like read it off the file?
Right. So, for example, if this program is allowing you to access all the names of those students and the GPA, and it allows you to show the front and the top and all those things are working, fully functional, I want you to convert that same program into this format, into queue format, which means you don't even have to write ADT and implementation of ADT. You actually just convert that particular program into this. So literally you probably need a push function. You probably need a front and back function, which you can see, just one line of code each. You probably need some kind of while loop to cycle through your entire queue. So you need to figure it out, how do I take that data, which is currently in the ADT format, and convert it into this format. So your assignment number 6, which is going to be much easier. The testing will be easier, and the code itself will be easier as well. It's much cleaner. Okay. All right. So I'm going to show you a couple of more things. The next thing I want to show you, function objects. So here I'm using functional library just for the camera. I'm using a functional library. There are a couple of other libraries. I might not be using them in this particular program. And I'm using this plus class from the functional library. Here's my variable add number of integer type. And just by looking at it, what do you think what's happening here in this line of code? Help me, guys. What's happening here? Yeah, I'm just simply, I don't have to do any submission. And this is applicable in many other cases as well, other types of data. So I'm simply saying, I'm going to give you two arguments, and add them together and store them in this num. So I'm expecting the sum of those two numbers in this variable here. And then I can also call function add. Function add is on my local variable. It's my local variable. Local function. I'll show it to you. I'm passing the add number. Add number is a function, and I'm passing that one. And I'm passing 34 and 26. In other words, this function and these two numbers are being passed to function add. Let's look at the function add. Function add is a local function. It captures that particular sum and whatever the two variables are, and returns the sum. So you can actually do both ways based on how you want to do it. The first one is easier. It does the summation for you. And summation is not the only thing you can do. You can do other things as well, a lot of other things. Here is another string data type I have declared, and I have string 1 and string 2, and I call join string, and I say simply, I'm going to add those strings together. So I'm expecting hello there, they'll be concatenated, they'll be joined together. And let's look at this one here. So I have list array, or array of 1 through 8. And my int list is a vector. So I'm passing that entire list, and list plus 8. What do you think list plus 8 means? So I know list is this all data. What is list plus 8? So I'm adding this into my int list vector. Do you think that's the size in this case, or it's something else? Okay, so this will be my entire list here, which is size 8. So I'm passing that as an argument, and I'm going to add provide the what exactly I'm providing here, guys? Is it the size plus 8? List plus 8? Is that size? Yeah, each element. I actually forgot. That's why I'm trying to figure it out. What exactly is the second argument? Okay, we'll verify it. Let's actually verify it. So let me verify it. I actually forgot about that one. So here the first thing is it's just adding. We saw that earlier, which is this summation. This summation is 34 and 56 are added to 90. So that's fine. Then 34 and 26 are added here. That is 60. 34 and 26 are added. That is 60. And strings are joined. Hello there. Those are joined together successfully, as we can see there as well. And finally, this is what we were looking at, this list. So int list basically gives the, I believe this gives the size here. List plus 8, or maybe it's expanding the size. So that's the list, int list. That's where we were. I can verify again. I completely forgot what's the second argument. And the sum of this list is accumulate. So we call an accumulate function. So you have a very large list, can have a lot of different elements. You can simply call the accumulate. So start from the beginning of the list, end of the list, and basically allows you to add all the members, elements into a variable called sum. So you don't even have to manually add them. You just simply call that function. And we can also do the product here. Yeah, so we also have a function called accumulate, but this time to do product. So multiplies, so this is a multiply function. So start from the beginning and go all the way to the end, and this time multiply them. So multiplies basically will be multiplying all the values of all those members. So in fact, let's verify this. So product would be, if you have list of 1 through 8, this is the list. If you multiply each element with each other, you'll end up with this value, 40,320. So this is the summation. This is the multiplication of each one of those members together. And I'll check on that one, that what exactly is the second argument in that case. I think I read in the book, anybody has a book open? Can you verify? If you go to the vector, and when you pass a list, what is the second argument? And I'll check that one once we get out of the lecture. We have a couple of more things left. Let me talk about those. And this time, I'm going to talk about algorithm sample code. This one here for the camera, algorithm. So this code is available on the Moodle site. So in algorithm, make sure you have this algorithm library included. Algorithm library is included right there. So this algorithm library, and if you look at your book, you'll see a lot of very useful functions are there, including, let me get to that point, including you can actually have non-modifying algorithms do not modify the elements of the container. Some of them are modifying elements, some of them non-modifying. In fact, it talks about these are kind of algorithms. So modifying algorithms, non-modifying algorithms, numeric algorithms, heap algorithms. So these are the different types of algorithms. These algorithms allow you to fill something. It allows you to find something, search something, all those things. So all these algorithms are already available. So these are some of the non-modifying. For example, you want to count something. It doesn't modify your data. Find if, minimum, max, search, find lower bound, upper bound. All these are non-modifying algorithms available. And fill, of course, will fill your vector or linked list, whatever you're trying to fill, or stack, or remove is going to modify. Copy and sort, they will modify the data. So these algorithms will allow you to do a lot of things. And then we also have merge and reverse. Some of the numeric algorithms, we actually looked at the accumulate and heap algorithms. We might not have the demo file for the heap, but these are some of the things we can do with algorithms. So let's take a look here. So I have a vector, and I would like to fill this vector. So here's my fill function. This is the algorithm. It's a available function based on the algorithm library. So I go to the beginning, I go to the end, and what exactly I'm adding? 2. So let's test it. And by the way, what is the size here? I started with size 8. So how many elements I'm adding? I'm adding 8 of those elements with value 2. So you'll see 2 is added 8 times in that vector. So I'm calling the fill function to add 2 8 times. So it allows you to fill your vector. Okay. Now you also have a fill n. Fill n tells you where is the starting point and how many times you have to repeat. This is the value and how many of these you need to add. So if I use the same vector, let's use the same vector. So notice that I go to the beginning. Of my vector list, and I actually add 3 times, right there, 3 times of that value. So you go to the specific nth location and use a vector and fill that vector with that many times. Okay, so these are modifying algorithms. They modify your data. Now let's look at vector 2. Also size 8 in this case, and in this case I'm generating next number. I'm generating next number. The next number I think is a local function. You'll see the local function in a minute. So I'm actually going the beginning of vector 2. This is the end of vector 2. And I call the next number. Next number is right here. Next number is a simple function, allows you to generate some numbers. So it starts with 1 and increments by 1. And because it's a static number, and is static, static means when you revisit this the second time, it remembers the previous value. So next time it's going to generate 2, then 3, then 4, then 5. And it probably will happen 8 times. So this is another way you can actually generate 8 of those numbers, just to show you another way to add the data or generate the data. So this will generate those values. So when I run this function, actually it's right there, 1, 2, 3, 4, 5, 6, 7, 8. It generates the data. Then here, I go to the third location, and then I generate 9, 10, 11. 9, 10, 11, because it was a static function, or the variable n was static variable. So it remembered the previous 8 values, 1 through 8. It remembered that one. That was the original data. Then I said, go back, go to the third location, which is right here. Go to the third location. Oh, go to the beginning, sorry. Go to the beginning. And this argument says 3 times call that function. So it goes and calls function 9 is added, 10 is added, 11 is added. So you can see 9, 10, 11, and these are the remaining other values, 4, 5, 6, 7, and 8. So generate n will do something similar to fill n. Fill n. So fill n also allows you to go to a specific location and add data. So not only you can work with these numbers, you can also work with the characters and strings. Like in the previous sample, we saw how strings can be concatenated. So here's my char list. Notice that this list is not in any ascending order, or this list doesn't have, it has lowercase letters as well as uppercase letters. And I have an array of 10 characters. And I'm going to display it first. Then I'll use the position iterator. And then I say, okay, go to the beginning, go to the end, and find this particular character. So I'm looking for this character, start from the beginning, go all the way to the end, and call the find function. And this is part of your algorithm. So find function is a non-modifying algorithm. It just basically searches your entire list, in this case, this list. And if it's found, tell me the position. Tell me exactly where you found that particular character. So in our case, 1, 2, 3, 4, 5, 6th element. 6th element, that's where we are going to find exactly we're looking for D, sorry. 1, 2, 3, 4. 4th position. We're looking for D character. So here is our list. And when I hit enter, it says the D is found in position 4, as expected, because it was in position 4. So you have this find function. Now again, imagine this one if you have to write this find function on your own. So this will be a little bit more challenge for us. Here, we just call the function. Just add the algorithm library and call that function. This is the list. This is the end of the list. And then you tell what you're looking for. Just one line of code, and then you'll be able to figure it out if it's found or not found. You can further squeeze this one into 1 or 2 lines. Here, all I'm saying is, once you find that location, store that location in position. Yeah, I can also do cout. I can say cout, less than, and show me that particular position. it's going to show me that position. And I can take that position and display the data as well, or whatever. I can pass the data to another function. So I can do multiple things here. If the data is not found, just tell me that if it's not found. Also, you have another non-modifying algorithm function is called find if. If something is uppercase, lowercase, something is negative, positive, based on what type of data. So find if, go to the beginning of the list, end of the list, and see if there's an uppercase letter. If the uppercase letter is found, tell me where exactly it's found. In our list, we do have an uppercase letter, and you can see the third letter is an uppercase letter, C. That's the first uppercase letter. So when we do that, oops, run again. And the first uppercase letter is found at position 3. So 1, 2, and 3, and we were able to find the uppercase letter. Okay? This is probably the simplest lecture we have. I'm just repeating a lot of things. It's just each one of these libraries, there's a lot of repetition. I'm going to show you the last thing here, set and multiset, and we are all done. So I have to use a set library here. Just for our online class, set library is added here. And I'm going to create different types of sets. And first I'm going to create a variable of set type, integer set. And you will also see that other types of sets will be created as well. So first thing I'm going to focus on is integer set. And I'm inserting 16, 8, 23, 4 of these elements into, or 4 pieces of data into my set. Then I simply call and say display the data. And similarly, I have this greater integer a and int greater your iterator. So, and we'll actually use them. But first thing I want to see is if I'm able to display my set. Here's my set, which is added here. Okay, just for our students online, so 16, 8, 23. And notice that the data I have on the screen here is not in that order. So what happened to the data? The beauty of the set is that it takes the data, any order you put in, it's automatically sorted for you in case of set. So it displays 3 in ascending set, 3, 8, and 16. And the reason is, let's actually take a look here. So this int set, when the data is inserted here and when I display the data, it is actually sorted at that time. So then I insert another data set, which is this data set here, in integer set A. This is the data set, and you can see this data set is in a descending sort. The descending sort, because the way I declared my data set A, and this is how I declared my data set A. When I was declaring it, I was actually highlighting it. This should be in the descending, greater integer first in that particular variable. That's why my results are in descending order. So my results are descending order for the integer data set A, as you can see. By default, it's ascending order, but you can change the order by highlighting the keyword here, greater, and it will be descending. Okay, and then I can erase something here. Here I'm calling the erase function. When I erase So simply call the erase function. 59 will be removed, and my data set does not have 59 anymore. It's gone. Okay, then we have a iterator variable. Iterator variable is pointing, or it's pointing to the beginning of my data set A, and this is where my data set A is: 238, 156, 84, 39, 36, 30. That's my data set. So that's my data set A right there. So I have an iterator pointing in the beginning. Then I increment 1, 2, 3. So 1, 2, 3. So I'm probably here somewhere between 84 and 39. And what do? I call the erase function. And then I say, show me the data. When I call the erase function, after removing the fourth element, so remember we were between 84 and 39. So 238, 156, 84, 238, 156, 84, 39 is gone. The fourth element is gone. Then we end up with 36 and 30. This is really simple way to delete your data. Not only you're reading the data in an ascending or descending order, you're simply just removing just by calling one line of code. One line of code and you're removing it. Previously it was quite a bit of work for us to remove the data or add the data. Now help me understand the next line of code here. How do you describe this line of code? So I know it's a set. I know it's an integer set. It tells me what? It's a descending order. Greater values will be added first. And I'm saying, okay, whatever integer data set A has, assigned to, or take an argument of that one and give it to us in data set B. So data set B, integer data set B will be taking the integer data set A. Then I verify it. I say, okay, show me this data set just for verification purposes. Let's take a look. Let's verify it. So this is my data set A right now. So my data set B is exactly what our data set A is. So I basically took all the data set A assigned to data set B. Then what do I do here, guys? I basically remove all the contents, right? I clear it out and I verify it again. After removing all the elements, what do we have in data set B? Nothing, because we just called the clear function. So clear function to clear all the contents. So, all right, we're almost done, guys, almost done. So then I have another concept called multiset. So here I'm creating a variable of multiset type, names multiset. It's a string. Looks like it's a descending order. Similarly, we have an iterator. We'll come back to it. So let's say this is multiset data. I have these names: 1, 2, 3, 4, 5, 6. I have Donnie, Zippy, Goofy, Hungry, Goofy, and Donnie. So we have 5 of these. And looks like we have a descending order. So then we just verify this data first before we move forward. And you can see Zippy, Hungry, Goofy, Donnie. So it's actually descending order. That's exactly what we expected. And then I think that's it. That's all we did. And this was just to iterate it or loop through this one if we needed to loop through that one in our data set. So what did we learn from this discussion? We learned that we can use a begin function, end function to loop through that one. We can use an erase function, clear function, empty function. We can use an iterator to increment or decrement the position. We use the increment variable or iterator variable to loop through that one. We also learned we can easily copy the data set. We can easily erase things. We can assign things, all those things. So this makes your coding much, much easier. Now, do you think if I give you a traditional linked list or stacks or queues program, you can easily convert into this kind of method? That's exactly what we are going to do for assignment number 6. Assignment number 6, the program is available to you. Let me just show you the program. Here's my stack ADT. Here's my stack ADT, and we have gone through this kind of program before. So you have initialize stack function, empty stack function, full stack function, push, top, pop, these functions. So all these functions are available. These are virtual functions, and these are pure virtual functions. These must be implemented. So we implement them here. Here's my operator overloading for equality. My is empty function, is full function, top function, pop function, and the implementation is right underneath here. So that's where they are implemented here. So for the push, we actually can easily call the function push back or pop. So here's a push function. Here's our pop function underneath. So those functions are all available. And finally, we have our main function. Here's our main function. So I'm creating a variable of stack type. I'm creating a stack with 100 members. And I'm reading the data from a file. The file is also available on the Moodle site. So read the data, populate the data. Once the data has been populated, here display the data, go through the program. Now what we need to do is, instead of calling my own stack and checking in this manner, we are going to use our right here. We are going to use our STL for two ways. So you have to implement in 2 ways. You have to use STL list, for which you have to use include list library and STL queue. So you have to include the queue library and use the existing functions. Okay. Now, how do you want to do it? Do you want to submit 2 separate files, CPP files? I prefer you do that. So you submit a separate file for list program and separate file for your queue format. And also submit 2 separate screenshots, one for the queue, one for the list. Okay? I think we can easily do this one. This is the easiest assignment in data structure class. Because I'm giving you the program, all I'm asking you is make it simplify this program to just implement the functions we just talked about. And you have a file, sample files already available to you. Okay, that's all we have. Thank you very much. See you guys.